Hello, this is going to be my video tutorial guide to go along with the Git lecture for my scientific computing. Um, Wanted to do a video accompaniment for this one for, among other reasons, that I think the interface is constantly changing. There's a lot of places I'm going to say where to type and where to click. This is anomalous. This is the first such lecture that is not purely text-based within a command line. So we'll go through a video demonstration for that reason. So let's just begin with a few introductory slides. Why Git? So Git is, to my knowledge, the only reasonable way to share code or data files on the internet. There are such things as self-hosted, tarballs, compressed files, things of this nature. Oftentimes these are comparatively more difficult to work with. Many times they solve problems that Git doesn't solve, right? So they still see some use. But in addition to Git being quite easy to work with, it has really strong, currently, industry support from GitHub, which is financed by Microsoft, which makes it very easy to use. And there are very important open source products on there. So the Linux kernel, which is the most important and most used operating system in the world, is based on GitHub. So sort of nothing can happen to GitHub because the entire universe revolves around its existence, right? So if it goes down, someone will get it back online, as has happened in the past with other tools, right? So the combination of Git and GitHub represents sort of like the most advanced form of distributed collaboration, to my knowledge, that has ever existed, right? And it's a big deal. It should be a component of a scientific computing curriculum for this reason. All of the tools we've used this term are distributed over GitHub, and they are developed under Git. Git is a command line utility. In that way, it is not different from NeoVim or Python or LS or anything of this nature, Echo. Um, the lowercase version, which I stylize in this colored font here, that denotes sort of code or scripting, right? I use that to refer to the command line utility, which is distinct from the software of the same name. The software of the same name is essentially unimportant in a scientific computing context. It is an extremely interesting historical piece of software. It is very important. The way it was developed and written and is used and maintained is interesting, but none of these things affect its use for scientific applications. Separately from Git, this has always been, I think, a source of confusion. Unfortunately, the most popular way to use Git is with GitHub. This wasn't always true for a while. Bitbucket, I think, was pretty popular, right? And so at least they didn't have the exact same name, right? But so Git and GitHub are different things. GitHub does has its name for a reason, which is that it works very well with Git. But GitHub is a website, and Git is a piece of software that runs on your computer. And so in that sense, they are as different as, for example, I mean, any two things, right? Wordle is a website on your computer. Minesweeper is a piece of software that runs on your device. And these lines have been blurred quite a bit historically, because the classic example we would have used in the past is Microsoft Word is a program that runs on your computer, but now it is also a website, right? So it is confusing for this reason. GitHub used to be independent. I don't know much about its independence era. I think probably around the time me and everyone else started using it, we did start using it because they had a lot of financial backing and were able to market themselves and maintain very high uptime for that reason. Now it is owned and run by Microsoft. This is quite historically unusual. Microsoft develops the Windows operating system, which sees some use for scientific computing, especially in computer-aided design applications, right? The Linux kernel has historically been the #1 competitor for Microsoft. You could argue it's Mac OS. That's reasonable. So #1 or #2 competitor. Git was developed to support Linux kernel development outside of corporate structures. It is a free and open source product. Has no ownership. And now the Linux kernel is maintained on GitHub servers, which are owned by Microsoft. So in a way, Microsoft is at least footing the bill for itself and its biggest competitor, right? In practice, what has happened is that Linux is overwhelmingly used in cloud computing applications, in which Microsoft is also a major player. And for the most part, desktop applications are just going to be on Windows from now on because of corporate deals and the necessity of supporting things like Microsoft Office, right? So I think there was a much bigger historical conflict there than there is now in practice. And so I think for that reason, it is possible for like these two entities to play in the same playground without there being any conflicts, right? So because this is so confusing, and I will try and emphasize this today, and I'm going to try and emphasize it in a variety of different ways in my instruction, right? There's a difference between Git and GitHub, and it mostly matters for getting things to work. I don't think you have to think of them as different things in your mind, but when we refer to them, there's reasons we use one word or the other. Git is a command line tool. It is a piece of software. It runs on your computer. It is primarily used to work with GitHub. GitHub is a website, lives on the internet. For the most part, it is free, but there are paid options. Do not give GitHub your credit card. If they are charging you money, that means you should stop using them, basically, right? It is on the internet. It does not run on your computer. This means you can access it on your phone. This means you can access it on someone else's phone. This means you can access it from a public library. It might be difficult to use it without the software we have on our computers, right? But it exists out there. This is extremely useful. I am a professor. I have teaching responsibilities in more than one location. Oftentimes, I connect to the internet from different devices in different locations. All of my teaching materials live on GitHub, and I can access them from anywhere in the world, right? This is very nice. It is possible to use GitHub without the Git command line tool. I don't even know that it's that unpopular. Increasingly, people are doing browser only, but I would say that's still probably less than 1%, right? It is now officially supported through something called code spaces, which I find uninteresting, but do exist. So let's think about this in terms of like how we would use it in a class, in the context of this class, right? So here's the problem GitHub is solving for me as an instructor, and this is the problem that GitHub solves in scientific computing as well, right? So when I was in elementary school, the way things worked with assignments is an instructor handed me a piece of paper. I would write something on the piece of paper, and then I would hand the piece of paper back to the instructor, usually after some amount of time. That is a pretty unreasonable way to move around source code and any reasonable amount of data, right? So even just the periodic table of the elements has, from my understanding, dramatically more information attached to it than I could legibly handwrite and transmit in text to someone. There are, of course, ways to move it in text, right? There are textbooks about the periodic table of the elements, right? But even those are relatively small scale data sets compared to something like protein folding problem, climate modeling, things of this nature, right? Another problem we have with code, right, is that punctuation and indentation and white space are very important, right? It is often difficult to communicate these things with absolute disambiguity in a written format, right? And even if we print code out, frequently the way we want to use code is we want to run it in a computer, right? So really we want a .py file very often, or we want a .csv file, or we want a .wav file, depending on what we're doing. And since we want these files, we want this data, there's sort of not a lot of things that are built very well for these. A lot of times people are reaching for something like Google Drive or OneDrive or Dropbox on these sort of paid commercial plans that let you store files on the internet. I think those are probably pretty good at storing files of a certain size, right? They're not particularly good at storing source code. So they're not particularly good at storing .py files. I cannot tell you how many times I have seen a student copy-paste text from a .py file into a Microsoft, probably not a Microsoft Word document, but certainly into a Google document. And it instantly becomes unusable because the white space is not preserved and it actually changes the nature of the code, right? So the code becomes wrong by not using GitHub, right? So this is the problem we're trying to solve. And if I'm, a head researcher at a national laboratory, right, I'm dealing with the same problem, right? I have researchers probably, in this case, maybe around the United States, maybe if I'm working at somewhere like CERN around the world. Everyone needs to be moving code around, and we can't be dealing with things like where does this line end, right? The code has to work the same way on everyone's computer, so GitHub is a big part of that. So we have one other somewhat useful problem we can solve here, which is that here's two other things that I deal with on a semi-regular basis. I am working with someone on some code. We have different versions of the document. This is the classic, I think, Google Documents problem, but Google Documents doesn't work for code. And in a way, it's good it doesn't work for code. Git is a more stable and reliable and mature way to deal with this, even if it is perhaps has a steeper learning curve, right? But it does not allow accidents. It requires intention for there to be changes, right? So if I'm working on a group project with someone else, we want to use GitHub. And here's two examples of something. I've developed software collaboratively. For example, I'm a contributor to the Pandas library package in Python, right? I haven't contributed much, but I have, and so have probably tens of thousands of other people, right? And we've all been able to do that on GitHub without ever seeing each other in person. We don't necessarily speak the same first language. None of these things impact our ability to work on coding developments together. Separately, I have also written papers, academic research papers, papers that go forward to publication and undergo peer review, and then are published, and they're supported by public funds, so the full public can read them. When I write those papers with my co-authors, some of whom I haven't seen in person in years or things, we place the documents we are using to write our papers, our scientific publications, right? We place those under this sort of Git umbrella. And we keep track of changes to the documents, and that way we don't use Google Docs or Drive, right? Because we want to have total understanding of the changes made to the document. We don't want to admit errors or mistakes into the scientific process, so we avoid that by using the same techniques we use to develop the software that we were publishing about, right? Oftentimes, if you're moving more than one file around, it is nicer to put it on GitHub rather than start sending it as an attachment. So most of my work is sent about as hyperlinks to GitHub repositories, and I do this whenever I can. I'm a member of a research paper reading group, right? And we share links to essentially web pages that have multiple things on them maintained using this technology, right? So very frequently, I think, perhaps at an undergraduate level, there's often a final project and a final paper for a class. One way to solve that problem is that they live together on the same web page, and then the same people have access to them, and everyone can present from there, and everyone can make changes. And it's very, very difficult to make a change while claiming to be someone else, right? So it is clear who contributed to the project. So this is a good solution. And then the last thing is that I do this all the time, and there's no stakes for me because I have Git configured. And you may have done this as well. I taught you earlier this term about the RM command, which is a very firm form of deletion compared to many of the things I think we might be used to on a Windows device or a graphical user interface or Mac OS, right? I believe even Linux may have some sort of recycling bin. But when I type RM and do a command line remove of a file, that file is gone, and is extremely gone, and is gone forever, right? But it is gone forever from my computer, right? And so if it's gone forever from my computer, but there's an older copy of it that lives on GitHub, right? Then I simply go out to GitHub and bring the file back. So I'm currently giving this presentation from slides I developed and I maintain using Git. I deleted 7 chapters of this book by accident once. I think I even just typed something wrong by accident. Usually that would be terrifying, right? And usually I would have to be much more careful about what I'm typing in my computer. Maybe I wouldn't want to work on things while I'm too tired or something, right? No, it wasn't a problem at all. I lost 5 minutes of work, right? And it wasn't a particularly high quality 5 minutes of work, right? Because I was in the state where I was accidentally deleting things, right? So Git solved that problem for me, and it solved that problem very easily, right? A few commands, and I had all of the things I'd been working on back, even though in theory I should have deleted everything, right? So this is sort of the 90s aughts era save your work. Yes, save your work, but save your work and have Microsoft pay for the servers that are saving it, right? So we're going to step back and we're going to say, hey, let's use Git. Git has solved every collaboration problem better than anything else that we know of. It is the state of the art. It's the most advanced technology. It's been in use for around 20 years now. Let's use it. And I do want to give an example here of its use in the scientific community. So this is Lawrence Livermore National Labs page on GitHub. Lawrence Livermore is a major, I think of them as being most active in the renewable energy space. They're involved in a lot of other things, and we can just see what they're involved in by taking a look. They seem to do state-of-the-art contact physics. CUDA is a accelerated parallel computing framework that works on NVIDIA GPUs. They do differential and algebraic equation solving, high performance computing benchmarks, open quantum systems. All of this stuff, I can just look at the code for it. It's just right here. can click on most likely source, and then I can look at the file. This is not the same language we've been using this term. This is C++. But here's the code, right? I can just look at exactly what Lawrence Livermore National Labs is doing any given day. This was updated last month, and I can look at all of the history for this and see it's seems relatively recent. I guess it was renamed at some point, right? And this came from 2019, so I can just quickly look at 6 years of history on this document, right? To me, this is a dramatic improvement in the state of the art over conference publications going out once a year or journal publications going out once a month, right? So this is its usefulness in scientific computing. It is the best way to manage code. There are scientific problems for which code is the best way to solve the problem. So today, we're going to use a bit of Git and we're going to use a bit of GitHub. We're going to use Git to manage versions of our code. Git is variously called a version control software or a source code management tool. What these things just mean is that when we save some code, we're going to save the current contents of the code, but we're also going to save some notes about the history of the document. So we will have earlier versions that will also be saved in the same way. And this will all be taken care of by this piece of software, and we will not have to think about it. And this means if we delete our code by accident, we can just go look at an earlier version, right? And if we change our code, we can go look at an earlier version. If we change it and something breaks because we thought we were going to switch to NumPy and something was going to be faster, and now we don't remember the original, no, we just go back and look at the original. We are going to use GitHub to store this, and the homework for this week is going to involve you placing your code under GitHub so I can see it, right? And then we may introduce a little bit of Markdown depending on how much time we have. So let's go ahead and do that. And we're going to begin with GitHub. So let me get this ready here. I'm going to, at this point in time, let's see, I'm going to exit full screen. And I'm going to switch over to not having the slides, but instead having the sort of text layout of the same information. And then from here, I'm going to follow the steps that I have laid out for our work today, and I'm just going to demonstrate them as I talk through them. So the first thing we're going to do is we're going to go backwards. We're not going to begin with Git. We're not going to begin with the original tool. We're going to begin with the more recent website associated with it, which is GitHub. So we're going to go start with GitHub, where we'll need to create an account. I'm going to open this in I'll do a new private window. I'll bring this over here. Okay. So how am I going to do this? I'll need to create a free personal account and verify your email address. For you as a student, if you have access to an EDU address for any reason, I would recommend using that. GitHub is now owned by Microsoft, which means that in addition to its base functionality, which is quite useful, there's a lot of new toys coming out all the time. Microsoft is always trying to sell new products. Sometimes these new products are good to get experience on and listed on your resume, right? And if you have the .edu account, you can always choose to use the products. Separately, you might specifically want to not use a .edu account, and that's a good way to avoid using stuff that might not be free in a few years, right? So there's a delicate balance here. One of the reasons I'm really strongly recommending .edu right now, I think a lot of people really wished they had a GitHub Copilot license. Copilot was, and probably still is, the best generative AI for code development, and I don't think it was particularly good, but I do think it was the best. And so playing around with that and having a sense of the limitations of that tool instead of something like ChatGPT, which is not intended for code use, was of great value to students, right? And you sort of never know when something like that is going to happen. So we are going to follow this guide, and we are going to create an account. So I'm going to navigate to github.com. I'm going to click sign up for GitHub. Oh, I'm going to enter my email too. And I'll just use one of my academic emails. Okay. I'm going to create a password, and we will use a securely generated password. I did not expect that to show itself to you, so we're going to take this off screen and then generate a new password. Okay. I will create a username, and this will be CD example. I'm in the United States and I'm going to opt out of emails. That is up to you what you do. So I will click continue, verifying my account, do a visual puzzle. Let's see if I am smarter than the computer here. Let's see. Find the image that has the prize on the left held by the claw. Okay, and the machine on the right. I hope I can do this. I think it's this one. Nice. Okay. And then I should have gotten an email. We'll see if that's the case. And then let's see, I was CD example. Oh, I don't know my password. Okay. This is good to make sure I have the secure password as well. Okay. Let me set my password, and I'm sure you'll have to go through all of this yourself. Oh, I just got a little chirp in my ear that says I should have gotten an email. So we'll go ahead and reset my password. Let's see. Never trust your password manager. Let's see. Oh, it's rejecting my passwords. Let's see. Wow, that is very difficult to type. Okay, we're going to return to sign in. We're going to say we are cd.example dash example. Okay. I got the chirp. I'm going to verify. There we go. And since I used an EDU account, you have access to things like GitHub Education and so on. I'm not planning to use any of these right now. So there, we did it. It was a bit of an uphill battle there against the authentication, but we have succeeded. So we verified. Make sure you remember the email you use. Right. Many times students set up GitHub accounts and then believe that I, as the course instructor, will know their username, their password, or the email they used. That is not true. I know the username and the password and the email I used for this, and I also documented it, including almost accidentally showing my password live on YouTube. Right. And so don't forget things. And let's move on from there. Okay, so I'm over here. This is what Git looks like, and it's very helpful that the big green button over here, Create Repository, is sort of the most obvious thing. And why is that? Okay, I sort of wanted this to look a little differently. That's okay. I'm going to talk about the atomic unit of Git. When I talk about the atomic unit, that's the smallest amount of Git that is still something. And the smallest amount of Git that is still something is a repository. A repository is basically a folder, same as the folders or directories we have on our system, and it can have basically any kinds of files in it, right? In the files on our system, there's necessarily going to be something like an operating system there. We'll have to have probably a Python installation, right? These repositories don't have to have that. They're usually just a combination of code and data files, but they can be anything. Right, I could store a Python installation on GitHub. That would be a weird thing to do, but it is possible. So when we're working with Git, we are working with, by construction, like there is necessarily no other way to work with it, we are working with a repository. we are going to create a repository. And I see there's a little bit of textual issues there. Let's see if I can fix that quickly. Okay, so we will create a repository. I think I will just click this button. No, I don't want to click this button. We're gonna go to github.com. There is a create repository button here that is quite easy, but if you end up somewhere else, we are recommending using this plus. Click the plus. We'll click the plus here, and I am going to create a new repository following this guide. New repository. Okay. I am going to take ownership. I am the owner. I am CD example. It is possible to have more than one thing on your dropdown here. Here is an example. The GitHub organization also has an alias named Octocat. Octocat is the mascot of GitHub. It's very cute. It's a cat with 4 or 5 tentacles. I don't know why it's called Octo because I don't think it has 8 tentacles, right? So we're just going to leave everything here blank so far, and then we'll talk about the things we need to add. I'm going to create a new repository, and I'm going to name it Hello World. Okay. This is a scientific computing sample repository. Very good. Okay. And I am going to set visibility. I am going to use public. I want this to be visible to me and to other people, especially for now. I will leave this repository up and you'll be able to go look at it, right? It is possible to use private. If you do use private repositories, at least in the context of a course, usually you will be asked to also give your instructor permissions to those repositories, and that can be a bit of a headache. This can also be a good way, though, if homeworks are often you're not supposed to be looking at your peers, right? So you can use private repositories and only share with the professor, right? Often this is done with research before it's published, right? So I am going to not add a README. I basically never add READMEs, and I hear they can cause a complication, so I'm just leaving it unchecked. I am not going to add a git ignore, and I'm not going to choose a license. I'm just going to leave all this stuff empty. This is mostly if I'm creating a new piece of software. This is a software engineering thing. So a lot of this stuff's for software, not necessarily for scientific computing, right? So we'll go through with that, and we'll click Create Repository. And then I will take my hands off the keyboard, and we are going to place a pin in that for now, okay? And the way we're going to place a pin in that is I'm going to drag this over here into that page, and we will see that we have a command line open over here, right? So we have now set up what is often called a remote repository. Why is it called remote? It is not on my computer. It lives on a data center managed by Microsoft somewhere, perhaps in Seattle, where Microsoft is based, perhaps somewhere else. And so now that we have a remote repository, we're in a way going to be collaborating with ourselves. We're going to collaborate, our computer is going to collaborate with the remote Microsoft servers, even though we're going to write all of the code on all sides, right? And so in order to do that, well, there are ways to edit and test and run code on GitHub servers. It doesn't, to me, ever really make sense to do that. When I have my own perfectly good computer I'd like to do scientific computing on, or when I'm working for a major lab and they have a cluster computer that can do really high performance computing very, very easily, and it's perhaps already paid for out of my grant or something, right? So we have our remote repository on GitHub. Now we're going to make a remote repository on our local computer, and then we're going to connect the two repositories. Okay, so let's step through this. I mentioned repositories are like folders. I created, and I'm going to click over to it, I created a repository called Hello World. I'm now going to create a folder or directory called Hello World. I'm going to type, before I do anything, I'm going to show where I am. Print working directory, I'm in home Calvin, and I don't have any folders here. This is just a simulated computer I made just for the sake of this demonstration, right? So I'm going to make directory Hello World, okay? And then I'm going to note that the Hello World directory exists, and then I'm going to cd into Hello World. I am going to note that there are no current folders in Hello World, but I am going to note that I am in the directory, right? So let's go ahead, and that checks this box. I'm going to scroll down a little bit just to keep track of where we are. Okay, now we are going to add files. Why are we adding files? The point of this exercise is just to show how to keep track of files, so we're not going to focus on the content of the files. We have 10 previous chapters focusing on that, and so we're not going to do that right now. I'm just going to make an absolute minimal file, and that absolute minimal file is going to be Python hello world. So I'm going to go ahead and make a hello.py. I'm going to, I opened NVim. You can use text editor of your choice, but of course I'm recommending NeoVim. I'm going to press I to enter insert mode. We see the insert appeared at the bottom of the computer, or the bottom of the window, I guess. And from there, I will just type some text, and the text will be print, let's capitalize, world. And I will close that. And I'm going to press escape to get it back into normal mode. I'm going to press colon and then X to save and exit. Okay. So from here, I can see that I now have a hello.py file. I can verify the contents of the hello.py file with cat, and I believe I can run hello.py with Python 3. Okay, so I have some code. Let's get that into GitHub, right? And so I've completed this task. Let's scroll down. This is a directory on my computer right now. It is not a repository. To cause it to become a repository, I have to use the command git. I'm going to type git once, and it's going to put a lot of text on the screen, just so you can see what it looks like. There are many ways to use it. It is a complicated program. It is similar in complexity to NeoVim and Python, right, where there are many options, and it solves a different problem. Here are some notes, and I'll talk you through which of these we're going to use today. It is dramatically more complicated to use it the first time, and then it becomes easier after that, right? So this is all of the stuff that Git has. We're not going to use all of that. We're going to start by initializing our repository with git init. Now, that gave me some notes. We will deal with some of those notes later in time. But now I have initialized an empty Git repository in home Calvin hello world, and now there's this .git hidden file. Let me show you how to think about that .git hidden file. If I type ls, I only see hello.py, I don't see .git. That's because when it starts with a dot, it's a hidden folder. So I can use the A flag to see everything, including stuff that's hidden, and I can see, oh, here's the current folder, which we can see by typing ls dot. We can see the parent folder, typing ls dot dot, which contains only the hello world repository. We can, I guess I wouldn't ls.git. Well, maybe I can, right? I can ls.git, and there's a bunch of stuff in there that I never have to think about. It's hidden for a reason. I'm not supposed to look at it. And then I can ls hello.py. So these are all different things that are around. They are all files on my computer, but the files in the .git folder, those are managed by the Git software, and they're not files that I worry about. Oftentimes, after I initialize a Git repository, if I'm working in Git for any reason, I like to take my variants. And so I take my variants using the git status command. It's going to pop up not as much text as some of the earlier commands, but it'll be a few things to think about. So let's go ahead and type git status. What does this say? It says on branch master. Git has a feature called branches. Branches are usually used by software people to add new features to existing software. You have a piece of software that works well, but it doesn't do all the things you want to do. You create a branch of that has the new feature, but doesn't work that well. Once you get that software working, then that branch becomes the new software. I tend to not use that with smaller groups, right? So a lot of times we're going to see branch, and we're just going to be trying to pare down the complexity. We're not necessarily going to be trying to take advantage of the use of branching, right? It says no commits yet. That means there's no versions of our software made, right? This is a repository that has no history, it has no memory. It's the same as an empty folder. And I know you say, well, aren't there some files in the folder? Not according to Git. So there's files in the folder, but not files in the repository. And the perfect example of that is the very next line, untracked files. Git is aware of the presence of hello.py, but Git has not yet been instructed to think about the existence of hello.py. This is one of the things that differentiates it to me from other collaboration software. If I want Git to manage something, I have to tell it to. Sometimes that's good, sometimes that's bad. I often think that's good with scientific computing because sometimes I have very big files that I don't want to accidentally share with everyone because storage space isn't free. It might slow down the internet. Maybe there's something that I don't want to share yet because I'm trying to get some publications out of it and get my next grant or get tenure or whatever the scientists are trying to do, right? Maybe I'm worried it's wrong and don't want it to go out into the world until I validate it, right? So all of these things can happen. And then my last line is nothing added to commit but untracked files present, and it recommends using git add to track. Git will try and help you. It is a complicated piece of software, so it won't always help you as much as you would like. But in fact, the next thing I'm going to do is I'm going to conduct a git add. So let's scroll down. The first thing we note, the first thing we note is that there are untracked files. While we made a hello.py and have it in our hello world directory, it isn't yet tracked by Git. So we are going to tell Git that it should keep track of hello.py for us. And type git to let the computer know that this is a command for Git. I'm going to type add, which means we're going to put something into our repository. Then I'm going to tell it to do hello.py. I want to note, before I run this, in case you try this, this does not work if you are not inside of a Git repository. You have to do git init before you can do any of these other sort of operations. And if you change your directory to a directory that is not associated with a Git repository, then the commands will not work properly. So if your commands are not working properly, one thing to check is that am I currently in a Git directory? And one way to check for that is by looking for the .git hidden file with ls space -a. Okay, I'm going to git add this, and I expect there will not be any errors. And in fact, I believe there are not. Now I can verify that there are no errors with git status. And now we see much the same thing. We have not altered our branch, we have not altered our commits, but we are now tracking files. And so we change from red to green because we're successfully tracking something. Right, so let's go ahead and scroll down and get to the next step. I'm gonna have to take another sip here for my voice. Oh, let me see if I successfully corrected that typo. There we go, we note. Very good. With Git now aware of hello.py, we need to commit our changes, not or changes. We need to commit our changes for Git to save them. This is similar to sort of just saving a file in two different places, right? One of them is in the folder, one of them is in the repository. The Git does not use the term save, rather it uses the term commit. And that is sort of representative of it not being a file system, right? It is something other than just holding files, even though it stores data as if they are files, right? So we are going to use commit to save things. Ooh, I'm getting out of water. So we're going to use commit to save something to our repository. Now, this command has a lot of things attached to it, and I'm going to step through why that is. So if I type git commit, that's clear. If I type git commit, first of all, it doesn't work. And it doesn't work because when you're, especially as part of the scientific process, I think this makes a lot of sense. You're supposed to sign your name on your papers, right? So the first thing about git commit is it's going to attach my name to the changes I make. And right now I'm changing the Hello World repository from having no code to having some code. So someone needs to take responsibility for that change. And that's going to be me. So I am going to configure this. Now, in this case, Git tells you exactly what to do. I also wrote out some example, so I'm just gonna grab this. Can I actually do that? Is that gonna work? And wait, it grabbed the examples? Is that the one I meant? There you go, maybe that's a little better. So what do we have here? I think I configured my global user email. Just for a note on this, that's not a real email, and that's okay. Um, historically, before the prevalence of GitHub, the only way to contact people that made changes to any sort of code base was by the emails that were attached to the commits. Now, frequently, all of this runs through GitHub, and it is attached to GitHub accounts that have an attached email. I use different fake emails for different computers. This is a fake computer that I'm setting up for the first time, so it has a new fake email, and it says Calvin for class because I'm currently in class, right? So you can list whatever name you want. I find it helpful to list which computer I'm on, maybe which operating system I'm using, maybe which version of Python, like anything that you associate with the computer that is making the commit. Because we're configuring a command line, it makes sense to just describe that command line as is. I'm going to go ahead and clear this, and then I'm going to try and get a commit again, okay? Now, this is much less scary to you than it is often to other students in other classes. If you type git commit with nothing else going on, it's going to pop up a NeoVim window. That can be quite scary if you're not familiar with NeoVim. You are familiar with NeoVim. As much as I love NeoVim, it often feels slightly heavyweight for the process of just describing in a few short words the changes I have made to my code. So I am going to exit this. I'm going to press escape, Q, exclamation point. I'm saving without, or I'm exiting without saving, right? And then nothing works because I have to describe the changes to the code. So minimally, every time I commit something, it has to be attached to a person who signs it, and that person has to describe the changes. So I'm going to use the -m, lowercase m command for message. That is this part right here. And we did git commit. I also use the little -a. That means just save everything. I just sort of recommend that as a convenience. It's not going to be too important to use right now. So let me just step through this example, and I'm not going to use the A, but you can use the A. Git commit. I habitually type A, so I almost got A there. M, first commit. Oops, I misspelled first. There we go. Let's press enter. Very good. And then I can also do git commit A, M, second commit. Nothing to commit, so nothing changed, right? I'm now going to type git status, and we're going to see what changed. Okay, we are on branch master. There is nothing to commit, and the working tree is clean. Not too much to think about there. We're going to try and not think too much about branches. We're going to try and not think too much about working trees, but this means that all of our changes have been committed successfully. I'm going to take a brief aside. I'm going to alter the file, and then I'm going to show you what this looks like. So I'm going to nvim hello.py. I'm just going to get rid of this comma, save and exit. And now we can see that there's changes, and so I'm getting sort of the same description of the changes to my file system back. Put back the comma, and then now the code is the same version that I committed, right? So this is a way to measure differences between files. And that's one of the reasons it's called source code management, right? There's code, it's being managed. It's another reason it's called version control. There's versions that are being controlled, so on. Okay, so now we're going to talk about branches for a moment, and we're never going to have to talk about it again. I mentioned the atomic unit is repositories. Repositories have one attribute, and the attribute is which branch they are on. I mentioned this is usually attached to versions of software. Different people use branches different ways. I use branches as little as possible. I don't know that that's responsible, but I think that's common, especially with smaller groups, right? My branch is named master. Master is not a recommended term to use. It doesn't sort of appropriately or properly describe the branch, and it's a word that has had other meanings historically, so it's not used for that reason. And so both Git and GitHub have been shifting towards trying to use main instead of master, which makes more sense, right? It's just sort of the default branch. It's closer to Main Street. If you go to town, you're likely to end up on Main, and if you don't, you can probably find it from where you are. So I'm going to specify that my branch is named main. The reason I have to do this is GitHub is going to expect my main branch to be named main. So I'm going to just input this command once, and then I'm never going to think about it ever again. Git branch dash capital M main. And this sort of brings us into compliance with the existing standards for naming things. It avoids a lot of harmful terminology that is counterproductive to the scientific process. So now we have main, and that's what we want to have, right? That is the correct way to do things. And from here, we can now git status. We are now on branch main, which is the correct name. We have nothing to commit. Our working tree is clean. And now I'm going to press clear again, and we're going to introduce another topic. Clear on my terminal, scrolling down. We are going to introduce SSH, secure shell. That SH is the same SH at the end of bash, right? We are now working with the internet, and when you work with the internet, you have to think about security. That's how it is. I've introduced a few things that should be relatively important to us so far, and I'm going to link them now to a security context. I had to put my name on code changes. Someone could impersonate me. I had to put a description on my code changes. Someone could alter what I was saying. I had to write code and then publish it on, or well, I have intent to publish it on the internet. It's not yet published, right? I don't want my code to be altered to contain malicious code and then damage someone else's computer. I also don't want it to be altered and then I run it on my computer and it contains malicious code, right? So all of these are considerations. These are all things we should be careful about whenever we're running code and whenever we're moving code over the internet, right? For the most part, GitHub has made this as easy as possible. That doesn't mean it is easy, but it often means we only have to do the hard thing once. The hard thing in this case is SSH key generation. The way I'm going to make my code secure is I'm going to lock it, and I'm going to lock it with a key. The key is going to be a cryptographic key. It is a mathematical key. It is an algorithmic key. It is a numerical key. It's a bunch of numbers that have special properties, right? I'm not going to think about them too much. I'm just going to follow the recommendations of GitHub and everyone else, right? Everyone recommends the same thing. I've taught a class on cryptography. They're good recommendations, so I'm recommending it as well. And I am going to use SSH keygen. Now, I believe this will work on every operating system. I tried it on a few, but I don't have normal computers, right? I have computers that are used for cryptographic research, so they might have more stuff on them than they're supposed to. If this doesn't work on your computer, figure it out yourself, which is probably not going to be that hard. There's a lot of documentation on it, or ask me, and I'll help you figure it out. So I went ahead and I typed SSH keygen. You can specify a key type. I decided not to worry about that too much. So let me update that. Oops, more properly. Okay, so I typed SSH keygen, and now I'm seeing similar things over here as I'm seeing at the start of this, right? There is a slight difference, right? This location is different. Root SSH ID ED 25519 ID ED 25519. So this part is different, right? And that's just to do with the type of computer I'm using, right? But basically there's going to be something in a hidden SSH directory, and it's going to be called this. That is your identifier. That's what ID stands for. And then ED 25519 stands for the algorithm that is used to make the key. So it is the type of key. I could say, for example, I have a home key. I could say I have a key fob. I could say I have a student ID. In the cryptographic world, I can say I have an ED25519 key. Classic name of key was RSA, which is much easier to say, and a lot more of a hassle to work with now. So now we use this more modern key. Got rid of that T. Okay, let's scroll down. I'm going to use default everything here keep things as simple as possible while we work for this together. So there is a default here. So I'm not going to type anything. I'm going to press enter once, okay? Pressed enter once, okay? It took care of everything for me. This directory didn't previously exist. Not my problem. SSH keygen has taken care of that for me. I'm allowed to enter a passphrase and empty for no passphrase. If I enter a passphrase here, my keys are more secure if someone else gains access to my physical computing device. As a rule, I assume if someone physically has my computer, it's an unrecoverable problem. So I'm not going to add a passphrase. That is not best practice. You should add a passphrase. I'm not going to use one for now for the sake of this demonstration, right? So I separately, I find it stressful to type passwords while I'm streaming, right? So I'm not going to use a passphrase. What I'm going to do is I'm going to delete all of this when I'm done. You can make a passphrase and work with that. So I'm going to press enter. And I do want to point out that we are still looking the same here. Enter passphrase, okay? This was new over here, right? I'm going to press enter. Oops, I'm going to press enter. I'm going to enter the same passphrase again. Enter. Okay, and then I got this big cool thing. What's this? Oh, that's exciting, right? Let's see. My identification has been saved. My public key has been saved. My key fingerprint is this. Okay, here's a different, I think, key fingerprint, right? And the key has a random art image. This is so I can tell keys apart because they're numbers that are hard to see, and so this is just a visual representation of the number, so I can verify that the key is what I think it is. You may come to use these if you're using clusters more, and you may not if you don't, right? I also catted it here, so let's go ahead and take a look. Cat, and this is in root, oops, .ssh dash cid underscore ed 25519 pub, and you can tab autocomplete, of course, as well. And there it is. There's my key. Very exciting, right? And it is a different key than this one, but notice they both start with 4 A's, right? So that's something exciting over there. Okay, I have generated a key. So I have completed this task. We're going to scroll down. SSH key generation is attached to the idea of secure shell scripting. My understanding of the way to think about how this was done is historically there were multiple terminals attached to a single computing cluster, usually at a university or a lab of some sort, right? You securely attach to the remote, like supercomputer or whatever, using your terminal, right? And so you are sort of using SSH in a terminal to get into a computer. We can think of GitHub as a remote supercomputer. We can think of it the same way. And so I can type the SSH command, which, like Git, has no shortage of complexity, right? And we're not really going to use SSH in this class, but we're going to use it for one little thing quickly, which is we're going to use it to see if we can connect to GitHub. We're not going to do anything with GitHub. We're just going to use it to connect to GitHub. I want you to see SSH so you can say you've seen it, and GitHub tells me to do this to you. So that's why we're doing this. It is introducing additional complexity. It is intellectually and academically interesting complexity, so we've left it in for that reason. I'm going to use this exact command that is provided from GitHub. I'm going to SSH capital T. I'm guessing stands for target. Let's see what it says. Is there a T in here somewhere? I don't see one. Maybe my eyes are glazing over it, right? But and we are going to say git being the name of the service we're trying to talk to, at GitHub, excuse me, .com. Kind of similar to an email address, right? There we go. Now, what do I see? I see sort of the exact same thing we see over here. So let's scroll down to here. Okay, the authenticity of Coast GitHub, the authenticity of Coast GitHub. This will be easier to see if I put it at the top of my screen. Clear SSH T git at github.com. Okay, so I have the same things lined up over here. GitHub, same address. That's a good sign. GitHub has also generated keys, and their keys also have fingerprints, and we can look at their fingerprints. This over here says GitHub has a certain key. You should, as a rule, not use the keys on this website or in this video to see if they're correct, because these keys are subject to change. Instead of doing that, you should go to github.com, and you should see their public SSH keys. And we see that we have the ED25519 key listed here. To me, that looks the same as this one over here. DIVY3WZVV, right? We should check the whole thing. Check the whole thing. Okay. Now, I'm going to type yes because the keys match. There we go. We have permanently added GitHub to the list of known hosts. Oh, that means that I can connect to GitHub. And if you don't believe me, I can try again. So this works differently the second time. The second time I try to connect, I don't have to check the public keys. My computer now trusts GitHub, but GitHub does not yet trust me. Why not? Well, GitHub can't go to this web page and see my key, and I haven't provided my key to GitHub. So I sort of have given GitHub a key to my house, so GitHub can come take care of my cats or plants while I'm on vacation, something like that. I can't yet get into GitHub to, drop off surprise presents for them while they're at work, or whatever you might have a key exchange for, right? So I have given access to GitHub. I trust GitHub. I'm willing to work with GitHub. GitHub now also needs to work with me. So we have connected, we have verified the correctness, but we have only gone one way. I'm now going to follow this guide. I'll show it to you. We're going to follow this guide to set things up. Okay, so what are we going to do? We're going to return to GitHub. Oops, let's see, can I do this? That's not what I want to do. I want this to fill that screen. Okay. We are going to return to GitHub. We are going to in the top right, click my profile. The top right, I'm going to click my profile. That's not labeled. I'm mousing over it. Maybe you can't tell that's my profile. Might be a little bit easier to see it here, but not really. But I'm going to click like my avatar, perhaps. So I'm going to go ahead and click that. Okay. Maybe I'll say profile picture. Is that more clear? Profile picture / avatar. Let's try that. Okay. So I clicked on my profile picture / avatar. Okay. For me, a picture of myself. In fact, it is if I'm on my own device. I haven't uploaded a picture here. And I'm going to scroll down to settings and click. By scroll down, what do I mean? I'm seeing a few different blocks here, right? In the second or third block, I don't know how you want to count this. I was probably doing 0, 1, 2, so I'd say second. There's something that says settings, right? I'm going to go ahead and click on settings. There we go. Picture avatar. Settings. Let's click it. We're going to be taken to a different page. Okay. This is my GitHub settings separately. If you don't know how to find this, you can type this URL in. No problem. Okay. So we are now in settings. I'm going to scroll down. Within settings, left side menu, click SSH and GPG keys. What are GPG keys? Don't worry about it. Okay, we say middle of second group. Middle of second group, labeled access, SSH and GPG keys. Click. Okay. There's a center block here. I refer to this as the center block. Maybe that's not centered. Up to you. Excuse me. We're going to scroll down. I'm going to click new SSH key in the top right of the block. Top right, new SSH key. Click. Okay. I'm going to check and verify that I'm on the page. Add new SSH key. Add new SSH key. I'm going to give the key a title. It is going to be in class demonstration. It is going to be an authentication key. We're just not going to change the defaults. And now I have to copy my key into this window. So how am I going to do that? Now, my key was came into being in a certain location. A new directory was created by SSH keygen. I think I can remember where that is, but an easy way to check is to type SSH keygen and see that it's going to say it's right here. I'm going to Control Z out of SSH keygen. I'm not going to go through the process of creating a key. You can see that's my Control Z. It stopped SSH keygen. I'm going to give myself a few new lines, and I'm going to say cat root .ssh .id ed 25519, and I believe it was .pub. I think you really want to make sure you type .pub there, because that is your public key. Public as in GitHub is allowed to see it. The other thing is your private key, which is the key to your house that you don't want to share, right? I could spend a great deal of time talking about the importance and difference between public and private keys. For now, you should follow the guides. This is my public key, okay? I am going to copy paste this. And that looks okay to me. I'm going to add the SSH key. Add SSH key, paste it into key field. I don't think that's a line break. I think that's just how it's showing up. Let's go ahead and add SSH key. Key added, and we see we have in-class demonstration added today, never used read write. And I just got a notification in my ears that I got an email, and that email is from GitHub telling me a key was added to my account. Okay, so let's go back and check this. Now I am able to connect to GitHub. Now, I can't do anything with just SSH. I have to use Git to work with GitHub, but I can verify that my keys are set up correctly. And this is very exciting. So let's click back over here. SSHT git at github.com. Boom. Hi. And this was CD public. So I did the example on my other. Here's a CD example. Same thing. Let's scroll down. Okay. I'm going to clear this out, and I'm going to save my work. Wonder if I can get all of these open at the same time. Okay. There we go. Let's follow this here. Okay, so having done all of that, let's save our work. Now, our work is saved within this command line on our computer. It is not showing up here in Hello World. There's no code, there's no folders here. It's saying quick setup. That's not my code, right? That's other things. This is asking me to use their AI assistant or to invite people, right? That's different stuff. So what we're going to do is we're going to use a combination of git push after we've already done a git commit. Usually in my workflow, I git commit, then I git push immediately. We had to do some setup in between. Okay, I'm going to scroll up. We want to use Git to attach our local repository to the GitHub repository. By the way, I'm going to be following this almost exactly, but I'm going to step through it from my instructions, okay? So we are going to add a remote origin. This is the remote origin. It's remote because Microsoft's paying for it. This is not the origin because this is not where the code is going to be thought of as living. I'm going to think of this as being public code that I have a local copy of, okay? We're going to need a name of this sort of repository in order to do that, okay? And now usually you can see this with the code button. Let me show you an example. Copy, paste and go. I think if I go to like pandas, this is the pandas library. A lot of respect for this library, so I'm using it as an example. we can click the code button, and we can see that there is an SSH option. There's also an HTTPS option. There's also a GitHub CLI, which stands for Command Line Interface option. I'm recommending SSH. Why? Quite secure. You can set it up once relatively easily, right? This, I do not like the process for setting it up. That's why I'm not teaching it to you. You're welcome to follow up on it on your own. This only works with GitHub, and I'm trying to teach you Git. It is possible that someday something other than GitHub will be what we use Git with. So I am reluctant to teach you this instead. So I'm teaching you SSH instead. To me, that's the perfect middle ground. We don't have this button yet. We instead have these things here to click back and forth. So I'm going to click the SSH button. I'm going to verify that it's clicked. One way to tell the difference is this is the same SSH name we were talking to before, and now we're simply providing some details. We're providing that at github.com we specifically want to see cd example hello world, and this now has a .git file ending. Okay, I'm going to copy this. Okay, and what am I going to do with it? Git remote add origin. Git, the command to tell my command line to do something related to Git. Remote, to configure the remote server to which my code is going to live on. Add, I'm going to create a new remote server. I'm going to set up a new remote server, and I'm going to call it the origin. I'm going to say it is where my code lives. Just copy paste this. You don't have to think about it. All of these options can be changed. This is a good series of defaults, so this is good to work with. If you're working at a national laboratory and someone tells you to do something else, you should do that, and it will probably be as easy to understand as this. And then we copy paste. And I'm going to go ahead and press enter. Just like that. No changes to Git status because nothing's changed here. Okay. Now, with all of that work done, we can finally push. Push takes the code I wrote and it pushes it to the other side of the table or up onto the remote servers. I'm going to type git push. I'm going to clear this so we can see all of git push. I'm going to type git push. Some stuff's going to pop up, and it's basically going to be referring to how Git is using the internet. Right now, we haven't done anything on the internet in this command line. I'm hoping it's connected to the internet. And so I'm going to git push, and then we're going to see some descriptions of the internet. Oh, did I not do something? Oh yeah, I didn't. I skipped a step, right? You can see it right here. I have to git push u origin main. So let's go ahead and do that. Git push u origin main. And there it works just fine. So I'm going to update these instructions to make sure they are correct. Wow, where was that? -u origin main. I believe you don't need the -u, but I thought I tested this and I thought it worked without specifying origin main as well. I think now if I say just git push, it will be fine. So I had to do that once. So let's go ahead and save that. And let's make sure this all works. And then I was also going to specify, this was not what we saw. What we saw instead was the quick setup. Locate the quick, let's see, copy paste, quick setup if you've done this thing before. And when we located that, we clicked the SSH, select the SSH option, copy the address, or existing repositories. Okay. Let's see, find the code button in the top right. Okay. We'll get that changed, and that should be publishing. Okay, we've git pushed. Okay. I'm going to refresh this page. I'll leave this page open. This is what it looks like now. I'm going to make this big. Calvin for class. That was what I configured my name to be. First commit. That was the message of the commit that I made 27 minutes ago. That was when I made the commit on my local device. Okay? Hello.py, that's the only code in here. 100% Python. And so this is the hello.py code that I wrote. Okay? There's only one branch, that's the main branch. I only have a main branch. Okay? We're going to click this and we're going to look at it. This is the code that I wrote, and it all showed up on my computer. Okay? I'm going to press the back key, just like, Alt, left arrow, something like that, and to get back to this page, or I can click back on code, right? Why is that going down? I find that annoying. There we go. Okay. Excuse me. Okay. So, we also saw we were enumerating objects, blah, 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 so on, right? So this did exactly what we said over here. Oh, I need to refresh this to make sure it's correct. Okay, finding names in web browser, navigate to the repository page. I think I can refer that. This is where we said place a pin. Where did we say place a pin? Placing a pin right here. Okay. I'll add a link there. Want to have good notes for this for everyone that's using it. Okay. Okay. And we were pushing, finding names. Okay. Place a pin. Perfect. Okay. Or we can find the code button. Copy the address. Okay. Very good. That should be sufficient. And I think now we have all of our code working and running well. Okay. Let's just follow through on a quick example of, now that we've learned all of this stuff, we can just go through and quickly do some changes with many fewer steps. Let me show you an example. Currently only have hello.py. Let's just add a new file. Yeah, I was going to be polite with an exclamation point. Bye. Okay. Exit that. Okay. I could get status here. Git add by.py. Git commit am. Adding by. Git push. Done. Shows up down here. I pressed F5 to refresh that. You can also just press this key. So that's all you have to do once it's set up. And hopefully that feels a lot less scary. Okay. You can do this in a single copy paste. You can do it in a single line if you need to. Let's now show an even simpler example, which is that we change an existing file. Is it by.py? That sounds right. We're going to alter this to be goodbye. I don't know how to spell goodbye. Okay. Okay. Now, I only changed the file. I don't even have to get add. I'm just going to git commit am goodness. It's a silly message. Git push. Updated just now. Goodbye. Okay. Want to show you one other thing. Usually I would like you to have sort of a partner you're working with make some changes to your files. Not the easiest thing to set up, especially during a demonstration. So instead of having a partner, I'm going to alter something on github.com, which sometimes you might want to do. This is pretty sketchy if you're working with code. It's very sketchy if you're working with HTML, because invariably working with that stuff in the browser isn't going to work great. We're just going to make a very, very minimal change. I'm going to alter hello.py. How am I going to do that? I'm going to click on hello.py. Okay. This is where we are. I bet there's not two T's in editing. That seems silly. Did my other edits come through? Okay, let's get rid of that T. I'm like almost positive there's not two T's in editing. I don't actually know how to spell any of these words. Okay, so I'm going to click the file. I'm going to click the pencil icon. Where's the pencil icon? It's at the top right of the text, not the entire browser window. I think of this X as being the top right of the browser window. Doesn't really feel like the top right with smaller files, right? I don't know how else to describe this, but it's right here, okay? I'm going to edit that. And what I'm going to change, I'm going to say hello remote to local. That's because right here, this is remote. This is that's not on my computer. It's in my web browser, right? But I don't run GitHub.com, right? This is not my computer, right? I sort of own these bits, or I'm responsible for these text files here, but they're not mine. So remote to local. And I tried to use Vim commands. I have to just type here. Okay. Now I'm going to click commit changes. Again, in the top right, don't know how to describe this, right? Top right, commit changes. What's this going to pop up? This is going to pop up the exact same thing that gets popped up if I try and commit changes without a message. Okay. So I always provide that message. Here it's going to force me to provide a message, making a remote change to hello.py. I'm not going to add an extended description right now. You're welcome to do so, right? I'm going to commit changes. So committing changes, commit changes. Oh, my face is kind of blocking that off. Okay, so commit changes. Okay, very good. Now, if I were to pull up, I have a browser window somewhere. Where is it? I can look at hello.py. It's still saying the same thing. Why wouldn't it? I haven't done anything to cause the files to change on this device, right? There's different versions. There's different versions being managed, right? There's a remote version. Right now there's a local version. The remote version is more up to date. I know that changes were made to it. Perhaps I came into work in the morning and someone else had been working on their own computer overnight. Perhaps for a while I had a colleague in Italy that would commit things before going to bed, and then I'd grab them in the morning, right? And then I would push my changes in case, there was someone in Korea or something working on it, all around the world. So what am I going to do? I pushed to get my code onto GitHub. I'm going to pull to get GitHub's code onto my device. See all the same nonsense I usually see. This is mostly what I'm looking for. Which file changed? And there it is. The code runs, prints as expected. That's the end-to-end process. And this is how to use Git and GitHub. Just going to introduce the sort of associated exercise that I recommend doing with this real quick. So here's what I think is a good use of our time. This term, this class, this book begins with 4 assignments: Python, NeoVim, Shell, and NumPy. And those 4 things all put together get better and better, in my view, different views, right, at solving the income tax sort of piecewise equation problem. We start with just a piecewise function with some Python code that looks a little messy. We calculate some point-intercept and slope-intercept forms, and then eventually we vectorize everything, right? And so we move closer and closer to the scientific computing standard. Those correspond to version changes. So to make sure you're comfortable with working with GitHub, make a repository for taxes.py. Put your first version in there, write a commit message, commit it. Put your next version in there under the same name. So edit taxes.py. Always have only just one py file, or perhaps maybe you have multiple py files for a version when we had like intercepts and tax and so on, right? Edit it, change it, commit that version. Really, the proper way to document these files is to have different versions of one file. We weren't doing that earlier in the term because it didn't really make sense. I was imagining you just steadily updating the same thing on your device, but maybe if this was homework assignment, I had to ask you to turn them all in, right? So there has to be different ways to think about this. In my view, the correct way to think about those 4 changes from the first 4 chapters is it is different versions of the same piece of code. So create a repository that reflects that using the same techniques I showed you here. And I will post a solution after I upload this YouTube video. But that is the exercise that accompanies this chapter. Thank you so much. This has been Git for Scientific Computing.